Hello, I welcome you all in this video tutorial. It is based on basic blocks and flow graph. This part is basically dealing with the code generation activity. So what is the meaning of basic blocks and flow graph? So basic block is nothing but when we have the collection of statements together that will execute in a sequence or that will execute together, that is called as basic blocks. And the representation of intermediate code with the help of some graph like structure, it is known as flow graph, where with the flow graph we are representing the basic block execution. So these two terms, that is basic block and flow graph, are like both are connected to each other. Basic block is nothing but the block containing statements which will get executed in a sequence, and that representation of execution will be shown by flow graph. So we will see one by one along with the examples. So let us start with the basic blocks. So what is basic block? As I said, it is nothing but set of statements or collection of statements that will always execute in a sequence one after the other. That means statement 1, statement 2, statement 3 up to statement 1. So the execution sequence will not get like disturbed. It will be in a sequence. So what we have to do, the very first job is to partition the sequence of 3 address instruction into the basic blocks. That means which 3 address instruction we have formed for the given source code, we have to construct or we have to partition that 3 address code instruction into the basic blocks. That means we will be creating block 1, block 2, block 3, block up to block n. So we cannot say that how many blocks will be possible. There are some rules. On that basis we will create the block, but the 3 address instruction we have to partition, we have to divide, or we have to make the classes into the different blocks. So how we can start with this? We begin a new basic block with the very first instruction. So first instruction will form the first block formation or the starting of first block. Then we will keep adding the instruction until we meet either a jump or conditional jump or a label instruction. So we will start with the very first instruction, that is nothing but the beginning of a block, and we will add this statement in that block till we get a jump, conditional jump or label statement. If we get this particular statement, then that block ends there. In the absence of jumps and labels, the control proceeds sequentially from one instruction to the next. When we do not have any jump instruction, when we do not have any go to or label included in the 3 address code, at that time the control will start from first instruction and it will end at the last instruction. That in that case we will be having only one block of that 3 address instruction. So let us understand the characteristics of basic blocks. So basic blocks usually do not containing any of the jump statements. There will not be any possibility of having branching or any halt in the middle. All the statements will get executed in the same order in which they are appear or in which they are formed, constructed together, and they do not lose the flow of control of the program. That means with the introduction of basic blocks or with the formation of basic blocks, the flow of control is not at all disturbed. It will remain as it is. So these are the 4 characteristics. I repeat the characteristic. There will not be any jump statement, there will not be any branching or any halt in the middle. All the statement will executed in the same order in which the 3 address code is formed, and due to the basic block introduction, there will not be any loss of flow of control. Now let us understand the example of basic block. So here one expression is given to you, a equal to b plus c plus d. We have already seen this example. So for this expression, generate the 3 address code. So cd operator and determine the precedence of operator. So b plus c will be evaluated first, assigned to t1, then t1 plus d will be there, assigned to t2, and the t2 will be assigned to a. So in this way the statements here will get executed one after the other. That means first b plus c will be computed, then that result will be added with d value, and the entire expression value will be assigned to a. So there will not be any disturbance between the execution flow. So first statement, second statement and third statement will be getting executed one after the other. So this is what the example of basic block. Now we will see exactly opposite case to this. So the expression is if a less than b, then 1, else 0. So for this expression we will be forming a 3 address code. So 3 address code looks like this. If a less than b, go to 4, that means current statement plus 3. So 1 plus 3 equal to 4, go to 4 and have t equal to 1. After that t equal to 0 and go to 5. So go to 5 will be the it will go to 5, that means fifth number statement will be nothing but the statement after exit of the if. So now in this way, in this particular 3 address code, just look at the first statement. If a less than b is true, that means we will be going to statement number 4. So at that time statement 2 and 3 are skipped, and this will violate the principle of basic block definition, which is nothing but the statements are executed in a sequence as they appear. So the statement as they appear are not getting executed. Here when true condition is there, we are jumping to statement number 4. So statement 2 and 3 are skipped and not getting executed. So this is not a basic block. So you please understand the example of basic block and a block which is not called as a basic block. So both examples are shown here. Now we will be seeing in what way we can partition the given intermediate code into the basic block. So one intermediate code will be given to you, 3 address code will be given to you, and you have to partition that intermediate code or 3 address code into the basic block. So for that matter, just understand 2 rules. First one is determine the leaders, and second is determine the basic block. So we'll see one by one. In the first rule, that is determine the leader, what we have to determine? We have to determine the starting instruction. So first determine those instructions in the IC that are the leaders. That is nothing but the first instruction in the basic block. So to become a leader, there are some choices or there are some criteria. So if the statement follows those criteria, it will be called as a leader. So what are those criteria? Understand. First one, the very first statement of the code will be called as a leader. This is the first criterion. Second is statement that is target of conditional or unconditional go to statement. So the statement which is nothing but specified into the go to, it is also called as a leader. Okay, so we have already seen such examples here. Let's say go to 4. So in a certain block, if you observe this type of statement, go to 4, so this statement number 4 can become the leader. This is the meaning. So the statement which is nothing but the target statement appear where? In the conditional or unconditional statement and its go to part, go to and certain number of statements. So that can be a leader. So first statement of the code is leader, then the target statement given in the conditional and unconditional go to statement can be leader, and third is nothing but statement that appears immediately after go to statement. So after go to, whichever statement is there, that will become the leader. So the statement after the go to will start a new block. This is the meaning. So we will see that in the coming examples. Second rule, it is about determining the basic blocks. So on what basis we can determine the basic block? All the statement that follow the leader statement, that is first statement including leader statement, till the next leader appears, that will form a one basic block. That means statement 1 to statement 5 will form a basic block if statement 6 is a new leader. So 1 to 5, this combinedly forms a block 1, and 6 onwards will be the block 2. The first statement of the code is called as first leader. The very first statement will be called as first leader, and the block containing first leader will be called as initial block. So whenever we have beginning of the code, that will be called as first leader, and that leader to the next block. So the very first block will be called as initial block. So we will understand now what is the flow graphs. So flow graph is a kind of directed graph where the flow control information is added to basic blocks. So first of all, a 3 address code is there. From that 3 address code we will be forming basic blocks, and now we will be assigning some direction to those basic blocks. Some direction, some transitions will be shown to the basic blocks that will be showing some control information, flow of control information, and such directed graph will be called as flow graph. So what is basically importance of having basic blocks and flow graphs? these basic blocks and flow graphs are the important IR representation entities. So with the help of flow graphs and with the help of basic blocks, the code generator tools or code generator application will be able to understand the entire flow of control of that particular given code. So once the code generator understand flow of control, the code generation activity will be faster, and like it gives the clues like which are the variables present, what is the first block getting executed, which is the second block getting executed. So once the code generating tool understands the block structure, it will be easier for that code generator tool to assign the register or to allocate the memory. So the process becomes faster with the help of flow graphs and basic blocks. So once intermediate code is partitioned into basic block, we represent the flow of control between them by using flow graphs, a directed graph. Now nodes of the flow graph are nothing but basic blocks. So node will be in a graph, node will be represented by a block. And now under what condition we will be giving an edge from one block to another block, just understand. There will be edge from block B to block C if and only if it is possible for the first instruction in block C to immediately follow the last instruction in block B. So block B ends and block C starts. So then and then only there will be edge from B to C. Okay, this is the meaning. When block B ends, immediately if block C starts, then there will be edge from B to C. Now how this particular rule can be justified? So there are two ways. If there is a conditional or unconditional jump from the end of B to the beginning of C, then only, or in that condition also, you can draw the edge from B to C. That means the last statement of B contains go to beginning of C, then you can draw the edge. Or C immediately follows B in the original order of 3 address instruction, and B does not end in an unconditional jump. That means the last statement of B is not having any jumping, and C is following the block B. So in that case you can draw the edge. So let us understand the first example on this particular topic, that is basic blocks and flow graph. So first of all, a code is given to you, a source program is given to you, function is given to you. In the function, one declaration statement is there and for loop is there. One statement, that for loop contains one statement, and the function is returning some value. So let us understand how we can represent this function block into the 3 address code. So corresponding 3 address code is given here. I have already mentioned such examples in the 3 address code examples video. So please go and see how we can get the how we can get the 3 address code for functions, how we can get the 3 address code for loops, while loops, switch cases, and so on. So for this, first of all, f equal to 1, this is a declaration statement. Then the assignment, that is I equal to 2, I equal to 2. Now the condition will be mentioned here. If I less than x, then coming out of the loop. So go to, this is conditional jump basically. So go to, and the statement number we do not know. Let us understand the statement number first. So this will be statement 1, 2, 3, 4, 5, 6, 7, 8 and 9. So 9th statement will be this calling program statement. So we will be going outside the function. So T1 will be assign this f into I to f. So f into I is nothing but T1, and T1 will be assigned to f. So T1 will be assigned to f. Then we will be incrementing I value by plus once all the statements are visited in the for loop. So I plus plus or I plus 1 will be there and assigned to a temp 2, and the new value of I will be assigned to I, that is T2 value will be assigned to I, and we will be again coming to for loop to check the condition. So we will be visiting 3 statements. Statement number 3, that is what, 1, 2 and 3. Third statement is nothing but if I is greater than x. So in this way for loop goes, and when I value becomes greater than x, we will be coming out of the function and we will be return the call to the caller. So this is how the 3 address code is created. Now 3 address code is created, numbering is given here now. Now understand in what way we can form the basic blocks. So just write these statements in a same order, and as we discussed about the rules of formation of basic blocks, the very first statement will be the leader and it will start the initial block. So very first statement will be the leader and it has started the initial block. So f equal to 1, I equal to 2, and now next statement is conditional jump here. So what we have, conditional jump statement is here. If I is greater than x, go to n. So the first two statements will get executed sequentially, and thereafter there will be conditional jump. So there is no guarantee that this block will or this statement will get executed in a sequence. So we have created a third statement as a beginning of new block. Third statement as a beginning of new block, where it has the conditional jump, that is go to 9 when I is greater than x. So new block is created here where this is the statement becomes leader because it contains the go to statement. If you see the rules here, determine the basic blocks who can become the leader. The statement that is a target of conditional or unconditional go to statement, or statement that appears immediately after go to statement. So the statement that is target of conditional or unconditional go to statement. So we will see in this example here the conditional statement is there, go to 9. So this 9 statement can become the new block. So that is why this 9 statement can become the new block, and this statement, since it has some condition, it forms a new block. Then after that again the statement immediately after go to statement will start a new block. That is rule number 3. The statement immediately after go to statement will form a new block. So statement 4, 5, 6, 7 and 8, these statements are forming the new block. So that is block number 3. Now here go to 3. So go to 3 statement, what? If I is greater than x. So that is why the statement which is appearing in the go to part, conditional or non-conditional, this is non-conditional, go to 3. So this is non-conditional 3, that is why 3 is starting a new block. So in this way we have 4 blocks in this particular given 3 address code. So first block contains 2 statements. Because of this go to 3 has started a new block. Now immediately after go to statement 1, 2, 3, 4 and 5 statements are there, and immediately after this go to statement, new statement, go to calling program. Because of this go to 9, this is target, that is rule number 2. Target instruction or target statement is 9 statement. So 9 has started the new block. In this way 4 blocks are created. These 4 blocks can be like denoted like this. From block 1 to block 2 is possible only. Block 1 to any other block is impossible. Then block 2 to block 3 is possible. When I is less than x, this will be executed. So block 2 to block 3 is possible. Also block 2 to block 4 is possible. When this condition is like I is greater than x, then we will visit the 9 statement. So block 2 to block 4 is possible, and block 3 to block 2 is possible because of this go to 3 statement. So block 3 to block 2 is possible. So in this way at last you can show in what way these blocks getting visited. So this is the first example. The function block is given to you, generate the 3 address code for it, and after that describe the block structure, determine the block structure. Now let us see the second example. In the second example, one code is given to you. This is the source program. Now this source code, it is converted into its corresponding 3 address code. So now we have this as an input to construct the flow graph and to determine the basic blocks. So this is the 3 address code for this corresponding code. Now consider this code just like the rules mentioned in the earlier slides. First of all, find out which are the leader statement. So prod equal to 0 is the first statement, so it becomes the leader and it will start the initial block. Now you have to find out where this initial block ends and whether it has or it will be having the other blocks present in the code or not. So just see which are the other blocks present in the given code. So here this will be the first block statement, and see the go to statement present in the given TAC or not. So in the given TAC, no go to statement present except the last statement. So the first block that we have started from prod equal to 0, it is a leader statement since it is the first statement of the code. And just observe the last statement here. If I less than or equal to 20, go to 5. So this is what this statement given, go to 5. So the control will go to statement number 5. So statement 5 is over here. So the second block will be starting from this statement number 5. So we have two blocks. The leader of first block will be prod equal to 0, and because of this go to 5 statement, leader second block is there, and leader of that block will be statement number 5, that is T1 equal to 4 into I. So we have created two blocks, block 1 and block 2. Block 1 will consist statement prod equal to 0, that is leader statement, I equal to 1, statement 3 and statement 4, and statement 5 onwards we have all the statement listed in block 2. So two blocks are determined. Now we will generate the flow graph for the same. Now flow graph will consist of what? Flow graph will consist first of all the blocks that you have identified. Now which blocks you have identified? B1 and B2 are identified. So now for that B1 and B2, see in what way control of execution flows. So now B1 block is presented here, B2 block is presented here. The last statement changed as if I less than or equal to 20, go to B2. That means go to 5 means what? That block 2 itself. So we have to make the change. So just see the statement is go to 5, but when you present that in a flow graph, you have to change that statement to go to B2, that is block number 2. So it will help the code generator tools to understand like where to move conditionally or unconditionally, that is where to jump. So block 1 to block 2 possible? Yes, it is possible, but block 2 to block 1 is not possible because there is no such statement present, conditional or unconditional jump that will take the control to B1 block. So what we have to do, just see whether block 2 to block 2 path is available or not. Yes, because of this 11th statement, go to B2, that means again it will go and visit the leader statement of block 2. That is why this arrow is shown here. Now we will see the final example, third example for the basic blocks and flow graph. Now the example consists of two for loops, nested for loops, and one more for loop followed by both of them. For this given code segment, the intermediate code or 3 address representation is given here. Now for this 3 address representation, we will find out the basic blocks, and based on basic blocks we will draw the flow graphs. Now here the code segment, its corresponding 3 address representation is given here. Now identify the blocks. So the very first thing that you need to look into the TAC is that just see the go to statement. So the first statement by default it becomes the leader, so first block will be start from 1. Now see whether 1 will be followed by rest of the statements or not, or how many statement will follow the statement 1. When I go and see the go to statement, that is jumping statements, so go to 3, so statement number 3 will be the leader of one of the block. Go to 2, so 2 will be the leader of one of the block, and at last go to 13, so 13th statement, that is T5 equal to I minus 1, will be leader of one of the blocks. So in this way 1, 2, 3 blocks, new blocks I have identified, plus the block that is called as initial block started by the very first statement of the given 3 address representation. So B1 holds the very first statement, then because of this go to 2 we have created statement 2 with a new block. So new block will be there, and that new block doesn't contain any other statement followed by it, just because we have one more statement like go to 3. That is why the third statement, from third statement onwards we have the new block. So the first block contains only one statement, second block contains again only one statement, third block contains statement 3, 4, 5, 6, 7, 8 and 9. So up to this go to statement it will contain all the statement into block 3. In the block 4 we will be having statement 10 and statement 11, and from 4 we will be having flow to the block 2. It will be conditional flow again. Then we will be having next block, that is I equal to 1, that is 12th statement, and from 13th statement onwards up to the last statement we will be having the last block because of this go to statement. So all the blocks and their corresponding statements are listed here, and as I said, you need to change the labels now. So when you represent within the block, go to 3 becomes block 3, go to 2 becomes block 2, and go to 13 becomes block 6. So in this way changes are made and blocks are listed. Now just draw the flow graph. Now for the flow graph, understand where the flow of control is moving and or it is transferred. So we'll start with the B1. So B1 to B2 flow is possible, B2 to B3 flow is possible. Also B3, because of go to B3, B3 to B3 self control is transferred. So B3 to B3 the self control is transferred here. Then from B3 to B4 is possible. From B4 go to B2, so B4 to B2 flow is possible. Then B4 to B5 is possible, B4 to B5 is possible, and B5 to B6 is possible, and from B6 to B6 again that flow is possible. So the control flow is shown for the identified block, and this is what the final answer for given example. In this way you have to first of all find out the TSE if not given. If TSE is directly given, from TSE find out the blocks, determine the blocks, and at last determine the flow between the blocks. So this is all about your basic blocks and flow graphs. Thank you.